Hi there, my name is Josh, and today I will be showing you how to transform your 3D scans into CAD models using ZEISS reverse engineering software. For the rest of the video, I'll refer to the software as ZRE. The workflow you use depends on the reverse engineering task and therefore the part design: geometric, freeform, or organically shaped. I will show you 3 methods that can be used to create a CAD file in the ZRE software. The first step of the process is to acquire the scan data. Today, we will be using the GOM-SCAN 1, but the same results can be achieved with all of our solutions. This controller is a standard geometrical part. To show you the workflow from scan to CAD, first we will scan the game controller using the GOM-SCAN 1. This solution is perfect for simple and fast measurements, for small to medium-sized parts, for printing or reverse engineering applications. The workflow assistant will easily guide you throughout the scanning process. You'll see the scans building up as we complete our part scan by scan. Immediately as new areas of our part are scanned, data will be added. After scanning the top and bottom, I have completed the scan of the game controller and now can polygonize. To get started on the right track for reverse engineering, let's align the part in GOM Inspect by using a 3-2-1 alignment. Now we can export the mesh easily to ZRE to show the first steps to create a CAD file of this part. Since we have a symmetrical part, let's go ahead and select half of our part to reverse engineer. Next, we can create planes from our mesh and align the normals with our coordinate system. If you would continue with the tools I have shown so far, you can create basic elements of this part. Let's create a body from these elements. Next, let's add a chamfer to this edge. Let's continue by adding more features. We can use our best fit via dynamic referencing tool to create one of these cylinders here. Now we can also adjust the diameter, height, as well as the reference axis. Next, we can combine our body and cylindrical surface and then extract a solid from these elements. Continuing this way, you can create the basic structure of this part. Next, I'll show you how to obtain this freeform shape. Let's isolate this spline and extrude a body using the spline. All other features in this area can be created with the tools I have already shown. These are all the typical steps to start reverse engineering a geometrical part. Using the tools I've shown so far, you'll reach this point. You see here that I have created all of the elements on the right side of the controller. By mirroring the same elements to the left side, I now have a complete symmetrical part. Here's the CAD model of our game controller. Let's use ZEISS Reverse Engineering to generate a tool for a freeform shaped part that we have already scanned. To transition this mesh to a freeform surface, I will use the feature Surface Approximation to Points. You can think of this tool like draping a cloth over the part to create the freeform surface. Next, we click our mesh, take a nice top view of our part, and select our parameters. For the segments, let's set the UNV values and set the iterations for this part. Let's now execute and close. Looking at our part, we can see that all details have remained and look good, so let's move on to the next step. We can now create a solid around our part. Next, we can give a nice top view of our part, move the corner of our cube, and then extend the sides to fully enclose the desired area of our part and click Execute and Close. Our final step is to subtract the freeform surface from the cube to create our mold. To do this, we will use the Boolean operations menu found here. For the type of Boolean operation, we will select difference. Finally, let's select our final body and export our new final CAD model. You can also easily create a CAD from a mesh with just one tool in ZEISS Reverse Engineering. This organic shaped figurine is perfect for this tool. The tool I'm going to show you is useful for generating a CAD model from a mesh, for example, finite element analysis, continuing reverse engineering, design and modeling, as well as creating CAD models for parts with an organic nature. This figurine was scanned with the GOMSCAN 100. Immediately, we can see the great amount of detail this scanner is able to acquire from this part. GOM Inspect comes with a complete mesh editing workspace. Here we can clean up our mesh, close holes, repair our mesh, and more. Let's use some tools to edit this mesh. First, we can close these holes and remove some features we do not want. We can align our mesh to a coordinate system and send this STL file to a printer for printing, or send it directly to ZRE to create a CAD file. Let's continue now in ZRE to see how we make a CAD out of this mesh. In ZRE, we can create CAD models from organic objects with just a few clicks. The resulting model follows the natural shape of our part. These methods show you how easily you can turn your mesh into 3D CAD models. If you want to know more on reverse engineering, or for more product information, or you have further questions about 3D scanning, please reach out to us via support@handsonmetrology.com or follow the link in the video description. Thanks for watching, and we'll see you next time.